did show NTP status, we got nothing there. Now we're at least running it. We're listening to NTP packets, but our stratum is 16 and we're unsynced, so, and we have no reference clock. Okay, so now you can see here, we didn't even see with the debug commands that I put on here, there was no packets. Nothing was picked up with our debugs. What you can see here though on router 0, the master, you can see here that we have some useful information here, like we transmitted the packet to the broadcast, and you can see here that we received a packet from router 1, which is the 192.168.1.1, and it so we know that that client wanted to partake in NTP, so then what we did was we transmitted a packet to router 1 and updated it with all of our information, with all the NTP configuration. So if we go back to router 1, we can see here now, we do a show NTP status, you see here that the clock is now synchronized. We have a stratum of 9, and our reference is 192.168.1.100, which is the NTP server. And you see here it gives us our time as well. So if we do a show clock now, you can see now that our time is updated to reflect the time of the NTP master server. So here you can see that the stratum is not 8, but it's 9, and this is because what you have with NTP is every downstream router that receives the NTP packets will actually increment the stratum by 1 every hop. So what you see here is router 0 has a stratum of 8, and so what it's going to do is it's going to send its stratum of 8, but router 1 is going to increment it. Every downstream router will increment it by 1. So it just takes the 8 and then adds 1 to it, and then you get the current stratum for router 1. So we should also see this activity on router 2. So again, it's going to receive a stratum of 8 from router 0. Then it's going to add 1 to that. So we should have a stratum of 9 as well on router 2. So let's go to router 2 and configure it to receive NTP packets. Again, we go under the interface for the broadcast, because we're using multi-access network here of Ethernet. Go interface fast Ethernet 00. Then we're going to do NTP again with the keyword broadcast, and under here we want to do client, so we want to listen for the broadcast from router 0. So if we do a show clock, you can see here that it's the old time. If we do a show NTP status, you can see that the clock is unsynchronized. Again, we have the old time on our clock of 1993, and our clock is unsynchronized with the stratum of 16. Now if I do a show clock, we're still seeing the old time here. do on router 0 is show NTP associations. See here, this is the actually this is the command that I wanted to show here. Let's go back to router 2, and by now it should have received this information. So now when we do the show clock, you can see now that it's given us the current time, 08:58 a.m. and you see here Thursday, September 17th, 2009. And what you can see here also is that it's given us universal time, which is formerly was known as Greenwich Mountain Time, GMT. So you can go ahead, you can go into to change this, you just go to global config and do clock, time zone, and then here you can set, like central CST. Then we would just set, the offset of GMT or UTC. But I'm not really worried about that right now. If we go back here and do a show NTP status, you can see now router 2, the clock is synchronized. We have a stratum of 9. Then it gives us our NTP master IP address here where we're learning it from, the time from. Again, stratum of 9. We're receiving a stratum of 8 from router 0, and we're just going to increment it 1, which gives us a stratum of 9. Now if we were to go ahead and take that and broadcast that timeout, what we would do is essentially say we had a router connected to router 2 over here on the other side and broadcast that out. What that router would do is would take the stratum of 9 that router 2 is giving and add one to that, which would give that router a stratum of 10.